Welcome to Robotics at the Frontier, Learning, Simulation, and Collaboration, presented by AI Frontiers. This episode highlights breakthroughs from 48 recent papers in the arXiv preprint server's cs.RO category. Today, the focus will be on how learning, simulation, and teamwork are shaping the next generation of intelligent machines. Featuring pioneering work by Tian and other leading researchers, this journey will reveal key trends, stories, and future directions in robotics. Imagine robots mastering new skills by simply watching online videos or by analyzing their own mistakes without human intervention. In simulated environments, these machines can train across endless scenarios, learning and improving independently. This is no longer science fiction. Research from 2025 demonstrates that robots are now capable of self-guided learning, with limitless potential fueled by advanced simulation and machine learning. Today's episode uncovers how these self-taught machines are becoming a reality. Robotics in 2025 represents a pivotal era for intelligent machines. The field now integrates engineering, artificial intelligence, and human-centered design, enabling robots to sense their surroundings, plan actions, and adapt in real time. This collection of 48 papers reveals a unified story of machines that are learning, collaborating, and evolving. The cs.RO category of the arXiv preprint server plays a central role in shaping both industry and everyday life, as listeners are introduced to the emerging generation of adaptable robots. Consider robotics as a symphony. Diverse academic disciplines such as mechanics, artificial intelligence, and human understanding harmonize to orchestrate machine intelligence. Research in this space is akin to composing the orchestra's sheet music, providing the structure for robots, the performers, to blend movement with cognitive abilities. The cs.RO category serves as a creative hub where innovative ideas are brought to life, with each research area acting like a distinct section in a well-coordinated orchestra. A fundamental theme in modern robotics is learning-based control and policy optimization. Here, robots acquire new behaviors through demonstrations, successful experiences, and even their own failures. Guzey and colleagues introduced wearable devices that transmit human movement to robots, while Fei and collaborators demonstrated that robots can enhance their capabilities by analyzing their most successful attempts. This process mirrors how a child learns to ride a bicycle through trial and error. The underlying technical method, reinforcement learning, enables machines to optimize their actions using feedback from their environment. Simulation and synthetic data are now critical for training advanced robots. Tian and colleagues developed Intern Data A1, an expansive synthetic dataset capturing diverse robot experiences. Simulation environments provide safe and rapid skill acquisition, eliminating the risks and costs associated with real-world data collection. Much like flight simulators are used to train pilots, simulated worlds now allow robots to practice complex tasks. Synthetic datasets built from virtual experiences are enabling robots to achieve real-world performance with unprecedented efficiency. Human-robot interaction and collaboration are becoming central in robotics research. Smith, Mira, and their teams have enabled robots to adapt dynamically to human partners, interpreting changing preferences and ambiguous instructions. These advances facilitate collaboration in both creative and practical settings, shifting robots from being mere tools to becoming genuine teammates. The key is making robots intuitive and responsive, allowing for seamless adaptation and cooperation in real time alongside human users. Several impactful breakthroughs have emerged from recent research. Tian and collaborators demonstrated that synthetic data can now rival real-world robot experience for training purposes. Howe's work with foundation models revealed that robotic skills can be transferred across domains, while Fei's self-optimization methods nearly doubled robot performance with reduced human oversight. Thimber's team drew inspiration from animal behavior, using peering movements to enhance robot vision through partial obstructions. Meanwhile, Chen's data distillation approach drastically reduced training times without sacrificing knowledge retention. A standout study, Intern Data A1 by Tian and team, marks a new era for simulation-driven robot learning. Their central challenge was to determine whether robots trained entirely in simulation could perform on par with those trained in real environments. The solution involved generating over 630,000 simulated robot trajectories spanning more than 70 tasks across 4 robot types, 18 manipulation skills, and 227 diverse virtual scenes. Their fully autonomous data pipeline required no continuous human adjustments, and the resulting open dataset is designed to democratize robotics research by broadening access for the entire community. A technical deep dive into Intern Data A1 reveals how Tian's team addressed the simulation to reality gap. Vision language action models were pre-trained exclusively in simulation and evaluated on both simulated and real robot tasks without any fine-tuning. The models matched the performance of those trained on real-world data, successfully transferring skills such as block stacking, pouring, and manipulating a variety of objects. A core concept was autonomous skill chaining, enabling robots to assemble new tasks independently during training. The broader impact of Intern Data A1 is significant. By lowering barriers for small laboratories and startups, the open-source release of this dataset invites global collaboration and fosters innovation. The democratization of robot learning is achieved by making cutting-edge resources accessible beyond large institutions. This work demonstrates how technical ambition can align with a social mission, inspiring a new generation of robotics creators to contribute to the advancement of the field. Looking ahead, the future of robotics is marked by scalability, adaptability, and optimism. The continued development of foundation models will allow robots to solve open-ended problems, while advances in data distillation will make state-of-the-art learning techniques accessible to all. Lifelong learning approaches will help robots grow and adapt in parallel with humans. Nevertheless, challenges such as the simulation to reality gap and ensuring safety persist. Robotics can be likened to a tree, with intertwining branches of learning and technology, continually bearing new fruit for society. To summarize, robotics at the end of 2025 has been fundamentally transformed by advances in simulation, learning, and collaborative systems. Robots are now adaptive, capable of teamwork, and driven by expansive datasets. Research by Tian, Hao, and Fei points to the imminent arrival of generalist robots capable of multiple flexible tasks. As the future unfolds, creativity will be fueled by ongoing challenges, and listeners are encouraged to explore, contribute, and imagine new robotic applications in their own lives. This presentation was synthesized using the GPT 4.1 model developed by OpenAI. Text-to-speech synthesis was provided by OpenAI, while images were generated by Google. Human experts reviewed the content for clarity and accuracy, though some oversights may persist. Listeners are encouraged to consult the original references for full technical details. All cited papers and studies have been referenced to ensure transparency and trustworthiness. Subscribe to AI Frontiers for the latest updates in artificial intelligence and robotics research. Join our channel to stay informed about new breakthroughs and key trends. Share your questions and aspirations for generalist robots and become part of a growing community shaping the future of intelligent machines. Thank you for exploring the frontier with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.